Hello Gophers, welcome to my talk, Go Module with Microservices and Monorepo, Clear Dependencies with Ease of Development. I'm Ryota Sawada, a CTO of Upsider. I try to jump pack a lot in the coming next 20 minutes, so let's get right into it. Today's agenda is as shown here. I will briefly touch on the basics of Go Module with a quick demo. We will then move on to going a bit more into Go Module internal and try to work out with Go Module in a private repository with another demo. At this point, I'll also cover what it takes to use a custom domain for this setup. After that, we'll have a quick refresher on the terminology of microservices and monorepos, making sure we set the common ground first. I will then discuss why this talk is about microservices plus monorepo. Once all of that's covered, I will give another demo to showcase all the topics covered: private repository, custom domain, microservices, and monorepo, with the power of Go module. For the final few minutes, we will also have a quick look at Go Workspace, which was recently added as part of Go 1.18. So a really quick look at some basics. Go module was introduced in Go 1.11, and Go 1.13 made it the default setup. It means Go module has been the default way for Go coding for more than 2.5 years. In a sense, it's not so long ago, but it's been a while already. Go module is about dependency management, and this removes the need of working under Go path. Let's have a quick demo on the very basics. If you're new to Go, hopefully this covers most of the basics for the remainder of my talk today. Firstly, all the demo materials are available in GitHub, github.com, rytswd, GoCon 2022, Spring. The file structure is as shown here, and we will use the demos directory. For the first demo, we will get into one basic. You can see the demo.sh and source directory. If you want to see what the final result should look like, you can find the equivalent files under source directory. We will be copying some files from there for the sake of limited time as well. Okay, let's kick off demo.sh. The first step is to create a demo source directory and get into the empty directory, and then run go mod init with some random module name. You can then find exact name in the go mod file. Straightforward. Now let's get some actual Go code over. I'm simply copying some code from source directory, so let's see what we got there. Now, this main.go essentially writes hello world, but uses a package called calce, and let's run it. Error, and that's because module dependency is missing. Let's run go mod tidy to fix that. See what happened to go mod. You can find the dependency to calce in the required directive now. Also, we get a file called go.sum, which contains hashes for each module. Now we can confirm that everything runs correctly with the dependency in place. We saw how Go module helped to pull in an external dependency for calce. In go.mod file, we had some dependency information, one for direct and another one for indirect. Indirect means those are the packages calce uses as its dependencies in this case. Also, we got a file called go.sum. This file is a bit longer and contains cryptographic hashes for each dependency. This slide explains how to read each piece of the information. If I had time, I would go much deeper into the Go module internal, but as we don't, let's move on. And before going into more about microservices and monorepo, let's also quickly touch on private repository usages. The previous example was deadly simple. We pulled in some code over internet and we were done. But how does it work if we were dealing with a private repository? How do we manage its version? And to answer that, we need to dive a bit further into Go module's internal. Go by default uses a proxy server for pulling modules. The proxy server is provided by Google. Its default behavior is often sufficient because if the proxy server cannot find the target module, it falls back to use direct access to the version control system. Speaking of the proxy server, I also have to touch on the checksum database, which is also run by Google. It is a database holding all the hashes for modules all over the world, providing a way to verify that module content has not been tampered. This obviously doesn't work for private repositories, and we will talk about this in a bit more detail later. As to version setup, you would often find this pseudo version notation. This will be important later when we talk about microservice dependency updates. So now we will move on to the second demo. In this demo, I will be using a very simplistic approach of using replace directive for private repository dependency management. And this is not how you should go about it, but it's one way we should know. Before starting the demo though, let's brush up on the replace directive use cases. The first one is to specify a version different from the original go.mod. The second one is to specify different repository, such as a fork repo for some specific fix you need. You can also combine those two to specify a version and a repo. And finally, there is a local path reference, and this replaces the module content with what you have on your local machine. With those details covered, let's move on to the second demo. So we move into the second demo, 2 with replace. This demo is going to be about making a service for cafe to serve some latte. Like last time, I'm starting a new directory demo source. And this time, I'll be making 3 modules first: Brazil farm, Colombia farm, and UK farm. Nothing special, just 3 directories, with go.mod file in each directory. Again, I'm copying some simple code from the source directory. And now, we've got Brazil and Colombia farm with the coffee directory, and the UK farm has got the milk directory. Let's see each file quickly. Brazil coffee has fruity coffee, Colombia with dark roasted coffee, and the UK with warm milk, perfect for latte. So with those 3 modules set up, I'm creating a service to use them all and naming it as go.concafe. First step is to go mod init as always. And for the sake of time, I'm copying the file over from the source directory for the implementation. Let's check the content. It looks lengthy, but very simple in fact. At the very top, in the import statement, we can see that the Brazil farm, Colombia farm, UK farm are all referenced. In the main function, we are calling make latte and make flat white function. In make latte function, we are referencing Brazil farm's fruity coffee and also UK's warm milk. In make flat white function, we are using Colombia's dark roasted coffee and the same milk. Let's try to run. Error. Missing module dependency again. It's telling us to use go-get to fix. So let's try that. Error again. And this is because Brazil.farm is not a real address. Here comes the replace directive to the rescue. Let's add the directive. And now go.mod looks like this. And we run go-get once again. Success. So let's also try go.mod tidy. Looks good. And we can see the go.mod file at this point. The required directive is added to the bottom of the file with this strange 000 version. So essentially there is no versioning here. We don't even have a go.sum either. Anyways, let's see if we can run main.go now. And this time, we can. So it pulled in the dependencies from the local files, but that version 000 we saw is a bit concerning. So replace works, but it does in a way that all the versions would become 000. And that means one change in some common package would automatically update all services dependent on it. And we will look at the solution later, but for now we need to talk about one more thing: Go module's environmental variable support. And there are about a dozen of environmental variables for which you can find all the information in the reference here. And we need a closer look at 3 of them: Go no proxy, Go no sumdb, and Go private. As the name suggests, you can specify path with Go no proxy for which you don't want the Go's default proxy to be in the way. By providing this variable, Go directly talks to the module path. As mentioned earlier though, this is actually similar to the default behavior. Also, Go no sumdb is about the checksum verification. This one is more significant than Go no proxy. By default, Go uses Google Run checksum database to verify the checksum, and if it doesn't find a matching entry in the database, it rejects adding the module. But the checksum database will never have the entries for private modules and repositories. Go no sum DB can be used to specify paths to not check against the checksum database. And finally, Go private. This is essentially a combination of Go no proxy and Go no sum DB. So if you have some module dependency hosted under a private repository, you should specify module path with Go private. And just very briefly about the module path. We often see paths such as github.com/org/package, but custom domain can be used as long as you have some server for that. The details covered here, and we will see it in action in the demo later. So finally about microservices and monorepo. Let's do a quick recap on the terminologies. According to Martin Fowler's article, microservices an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms. And a quote from Wikipedia, the goal is that teams can bring their services to life independent of others. And we will come back to this phrase shortly. Also about monorepo, you can find the following in Wikipedia. A software development strategy where code for many projects is stored in the same repository. Google, Facebook, and other large companies adopt monorepo approach. As to multi-repo or polyrepo, Amazon and Netflix are known to deploy that approach. So why microservices plus monorepo? As to microservices, it's probably pretty clear. It allows fast and easy development by teams when done correctly. I know there are more arguments around monolith versus microservices, but this talk is to enable developers to break down the seemingly high barrier for microservices. As to monorepo and multi-repo are both valid and have their own advantages and disadvantages. But I find that this quote from Adam Jacob, former CTO of Chef, is the essence. The default behavior of a polyrepo is isolation. That's the whole point. The default behavior of a monorepo is shared responsibility and visibility, and that's the whole point. So in theory, when combined, each team can release services independently while keeping visibility across teams, allowing sharing responsibility if necessary. To me, that's the environment developers would feel empowered and encouraged to work without boundary. In Go context, Go.mod is the important factor for microservices. The simplest approach would be to have one repository, one Go.mod for microservice setup. But that may not be the easiest setup for developers' point of view. Developers may need to juggle many repositories at once, manage commit history for each, while also maintaining versions and dependency between modules. Also, understanding the dependency for each module will be a challenge, as you need to check each and every repository to understand. Go module can make your life easier when used for microservices and monorepo, as new developer would find the single repository to find clear code structure and dependency, and ultimately ease of development. So putting all things together. So here comes the main demo. We will have a monorepo, and in that single repository, we will have multiple Go.mod files, each representing service, shared library, etc. We will not use the replace directive, and tagging and versioning are not strictly necessary thanks to the power of Go module. We do a quick version update and see how that works from the microservice point of view. Let's see it all in action. So, getting into 3 all-in-one for this time. For this demo, we'll use custom domain for modules. Firstly, we need server setup to handle the custom domain. Create a local TLS certificate for us to test, and for this simple demo, I add an entry to SC hosts to make the custom domain to resolve to my local host. Now start the server in the background, and then test the server with custom domain. Success, and we can see the meta tag with the name of Go import. And this is the key piece for setting up custom domain with Go module. Now, the custom domain setup is ready. Let's get back into the demo directory. The files are essentially identical to what we had in the second demo. There are some key differences though. The module name is updated to use the base address of go.rytswd, the custom domain that we just used. The same goes for the UK farm and Colombia farm. I have added an extra path of gocon main demo just to demonstrate how you can do that, for which you can find its setup detail in the custom domain handling server code. Let's look at gocon cafe. It no longer has the replace directive, so just one require directive. Each version is not full of zeros, and in fact, it has a commit reference and the commit date. There is also a new service called gocon restaurant. The require directive tells me that it has a dependency to the UK farm as well. But this time it has a different version, 011, and commit reference and commit date, different from gocon cafe. If you look at the recent commit history, we can see 5f5 starting commit is in there, which matches what gocon restaurant uses. Also, 33838 is another commit, which is used by gocon cafe, as we can see here. Let's just compile gocon cafe to make sure it's error-free. Also, I'll run gocon restaurant. It successfully served us a steak. Now, let's say we want to update gocon restaurant to serve something else. So I will add a new function in UK farm, this time ribeye steak. And I will update the gocon restaurant implementation to serve ribeye steak instead of sirloin steak. I can see my Vim is shouting some error, but ignore it for now and save the file. Now let's run go run main.go, which would fail. Vim was shouting about it. It's complaining about missing function. Why? That's because the version we use in this gocon restaurant is an old one and is not picking up the latest in my local module. So in order to get the latest spec, let's push the update in the UK farm to the GitHub repository. At this point, the new commit is available as a module path, so we can run go get-u to update the dependency. Note how I specify go private env variable here. The repository that go.rytswd here refers to is a GitHub repository, which was private at the time of recording. Because the checksum database won't have any entry for my private module, I use go private to skip the check. Also, I'm specifying @main for the version, which making sure I get the latest version, which is not backed by a release or tag. And go run main.go again. And there you go, this time, tasty ribeye steak from the UK. Before wrapping up, a quick summary of what we talked about. We had 3 demos, one with a very basic module usage, one with some private repository, and finally, one showcasing Go module to work with microservices plus monorepo setup. The microservices plus multi-repo approach may be simple to start with, but with Go module, monorepo is very practical and more empowering in my opinion. Obviously, it is not the only solution and may not be the right one for you, especially if you have strict access control requirements for code. But hopefully, you found that monorepo is certainly one possible route you can take. Finally, very briefly about Go Workspace. It is very recently introduced, but plays a significant role when you have the setup we saw in the demo. Let's have a quick demo on it. So now, we are in VS Code, opening the repository we have been using so far. As you can see, gocon cafe being open, and although we could confirm it compiles correctly, VS Code is showing errors around imports. And this is because go.mod is not being checked by VS Code, as there is no go.mod at the root of this repository. Instead of having go.mod, we can tell Go Workspace to handle this for us. The command is go work init, just like go mod init. Although at this point errors seem to have gone away, if you refresh the view, they do come back. Now, the main usage of Go Workspace is tell the editor environment that you will be working on the specified module by writing go work use with a path to the Go mod directory, so in this case go concafe. Once you do that, go.mod is read by the editor and all the errors go away. This even helps working on dependent module at the same time. Note that Go Workspace is a helper for development and is not meant to be pushed to the repository. Okay, this is the end of my talk. Here are some useful references for getting deeper into the details of Go modules. And with that, thank you very much for attending. Outside is hiring, we did use this microservices plus monorepo approach, trying to make sure each engineer gets all the power they need. If you're interested, please feel free to reach out to me in person via Slack, Twitter, or whatever media you like. Thank you very much.